All right, so I want to do one more short example on variation that has a combination of the two of them. So we're just going to use this page to read it and then do the work on the next page. This problem says that the average number of phone calls per day between two cities, so average number of phone calls per day between two cities is found to be jointly proportional to the populations of the cities, and then inversely proportional to the square of the distance between the two cities. So that would mean I'm going to use A for the average number of phone calls per day between the two cities. Has been found to be jointly proportional to the populations of the two cities. So maybe I'll say P1 and P2. And then inversely proportional to the square of the distance. So I'll be using a D for that. So my equation is going to go something like this. A equals, always the K comes next. This is jointly proportional to the population of the two cities. So I'll say P1 times P2. So that's joint variation. And then inversely proportional to the square of the distance. So inverse needs to go underneath. So that's going to be D squared under there. All right, so I'm going to take a second and write my equation on the next page. All right, and so then they gave me some information in the next part of the problem to tell me, so I can figure out K and write my equation. The population of Charlotte is 1,500,000, and the population of Nashville is about 1,200,000. It's 1.5 and 1.2. All right, and the distance between the two cities is about 400 miles. The average number of calls between them is 200,000. So this 400 goes on the bottom squared, and it said 200,000, we just average, so 200,000. All right, so quite a few zeros in here. So first of all, let's see. I'm going to simplify this right side. All right, 1,500,000 times 1,200,000 divided by 400 squared. I'm going to enter that on my calculator. So when I did that, that comes out to this number here. So it's 11,250,000. I got 200,000 over here. All right, so I will divide both sides by the 11 million number to get my K value. Which gives me 0.0178 if I round it off. So I end up with my formula. My formula is A equals 0.0178 P1 times P2 divided by D squared. So I don't have any numbers to plug in here. I didn't have that in my problem, but this would be the formula I would use to do anything else with this. Thanks. Bye-bye.